Welcome to Newton's third law of motion. Newton's third law basically says this. We have two bodies, A and B. The force of B acting on A will be exactly the same as the force of A pushing on B. B pushes to the left, A pushes to the right. The same size of force, B on A and A on B. So, if A pushes B, B pushes A. With the same type of force, with the same size of force, but in the opposite direction. This is another Newton's third law when you're pushing the door. So, I push the door, the third law pair is the door pushes back on me. Another third law pair, if you're on the other side, is I pull on the door. The third law pair would be the door pulls back on me. So basically, my force on the door is going to be equal to the door's force on me. The air, in this case, is pushing the bird up. It keeps the bird up. The lift is pushing the bird up. So the air pushes the bird up. The third law force pair would be the bird pushes the air down, or the wing pushes the air down. Here's an example of a Newton's third law. We have a rocket which is accelerating into space. The fuel is being burnt and is basically being pushed out the back, so the rocket pushes the fuel downwards. If the rocket pushes the fuel, it means that the fuel must push the rocket upwards. So there's a force upwards, and this is the fuel pushing the rocket upwards. Here's a common mistake. We have a physics teacher, the weight and the reaction. That's the weight and the reaction. Some people say this is a Newton's third law pair. It's not a third law pair because it's acting, both forces are acting on the same object. Weight is acting on the teacher and the reaction is acting on the teacher. For it to be Newton's third law, A must act on B, B must act on A. So here we actually have two different forces acting on the same object. This is not the case of Newton's third law. What we have here is the weight, which is the force of gravity acting on the teacher, and the reaction, which is the normal contact force acting on the teacher. They're both acting on the same teacher. This is Newton's first law, the sum of the forces acting on one object. So this is some confusion between the sum of the forces is equal to 0 and Newton's third law. Here we have the reaction is pushing on the books and the weight of gravity. The weight is pulling on the books. These forces are balanced and we have a gravitational force and a reaction or electrostatic force pushing upwards. This is not Newton's third law. Here we have another example. The table pushes up on the books and the books push down on the table. So table on books, books on table. This is Newton's third law. A third example. We have the earth pulling down on the books. If the earth pulls down on the books, what is the Newton's third law pair? If the earth pulls down on the books, which is a gravitational force, it must mean that the books pull up on the earth. So this is what happens. The books pull up on the earth. You don't notice it because the earth is so big. So to summarize, if A pushes B, B pushes A, with the same kind of force, the same size of force, but in the opposite direction.